CNM25 technology example: 2.5 micrometer polysilicon insulator, polysilicon PIP. P for poly insulator I, and then polysilicon insulator polysilicon. Here also polysilicon inside insulator. That's all. This is the polysilicon. 1M twin well CMOS process. 4-inch wafers, 22 mm into 22 mm, 484 mm square, step vertical, 8 mask waved design, FEOL stages, N and P wells. Wafer processing steps: starting wafer general cleaning, Si silicon photoresist, initial pad oxidation 31.4 to 41.4A, nitrate deposition like this, NTB photolithography like this, SiO2, here Si3N4. 2.5 micrometer polysilicon, same here in this process, polysilicon insulator, polysilicon, 1M twin well same mass process, 4-inch wafers, same 484 mm square step rectangle, 8 mask design, FEOL stages, N and P wells, vapor processing steps, photoresist, as what we have seen like this, initial pad oxidation like this, nitrate deposition, NTP. Photolithography, and then this is nitrate etching, N-well implementation, nitrate etching, N-well implementation, SiO2, Si3N4. Here what is going on? Here same like that before, nitrate, N-well implementation. Here well oxide grow 3500 to 4500, nitrate stripping, FEOL implementation. Here okay. Here what is going on? Here well oxide grow, say in the same process, PAP, well oxide grow, nitrate stripping, P-well implementation, okay, SiO2, oxide stripping, P-well 7 micrometer, N-well 5 micrometer drive-in, and oxide grow 1500 to 1750, oxide stripping, N-well, P-well, Si. Oxide stripping, FEOL 7 micrometer, N-well 5 micrometer drive-in, and oxide grow 1500 to 1750, oxide stripping, N-well, FEOL, Si, FEOL, N-well, SiO2, pad oxidation here. 152 to 225, nitrate deposition like this. GASAD photolithographic, SiO2, N-well, FEOL, SiO2. Okay. Here this is the stop. Okay. And then here GASAD photolithographic, this one here for going on. What? Nitrate etching, field implementation. FEOL, Si, N-well, Si3N4. Here nitrate etching, field implementation, locus 10,000 to 11,200, nitrate etching here. Here this is nitrate etching. This is the nitrate etching. Okay, here is the defect. Here is the defect. This is see the defect. What nitrate etching? This in between this. Here locus in this nitrate etching same like this. No, what we'll do here? Gate implementation pre poly clean. Yeah, clean. What cleaning? Pre poly cleaning. Gate implementation. Gate here matching. Okay, making local oxidation of silicon. Yellow. Oh, yes. This is focus. Local oxidation. Yellow silicon. Okay. Here sacrificial oxidation, gate implementation, poly cleaning, MPLs, bacterias, PAP capacitor. Okay. Here polysilicon deposition, N-type doping. This one polysilicon deposition. So here only changes come on. Okay, and then here N and P wells, active areas, PAP capacitor, polysilicon deposition. This in between this N-type doping. Okay, polyphotolithography. See the different here. Yeah. Okay, so the same silicon, same polysilicon, fuel. No, here only different. Here only different. Okay, then N and P wells, active areas, PAP capacitor, polyolithographic wafer processing steps. Here polysilicon etching, sacrificial oxide stripping. Here, okay, what is going on? This, okay. And then N and P wells in FEOL stages, N and P wells, active areas, PAP capacitor, MOSFET, polysilicon etching, sacrificial oxide stripping, and then here gate oxide grooving. In between this gate oxide grooving. Okay. SI and then here also changes. SiO2, NL, PWell, N and PWells, active areas, PAP capacitor, MOSFET, gate oxide grooving. Here polysilicon deposition in between this poly1 photolithographic. Here what happened? This much. Okay. PWell, SI, SiO2, ML, here. And then in equal stages Once again I have to remember 2.5 micrometer polysilicon insulator polysilicon PIP 1M twin well CMOS process 4-inch wafers 22 mm into 20 mm 484 mm square stepper rectical 8 marks layer design the field stages N and P volts active areas PIP capacitor MOSFET wafer processing steps poly deposition poly 1 polylithographic. Okay, yeah, what is going on? Polysilicon etching. Polysilicon etching. That's right. Clean. This red not available. Okay. Etching. Etching. Not. This is etching. Not. Here also same. Okay. Then 8 mask layout design for wafer layers. Then N and P wells, active areas, PAP capacitor, MOS gate, MOS source, and a drain. Okay. Polysilicon after etching, what is going on? N plus photolithographic N type doping. Yeah, N type doping. So doping, what is changes? This might changes. Yeah, come back here. Okay. Here doing. Okay. Then red. This red not available. So this is the what? N plus photolithographic N type doping. This is the N type doping. N type doping. Photolithographic N plus photography. And then here which is suggests NMP wells, active areas, PP capacitor, MOS gate, MOS source subtray, and then wafer processing steps, photolithographic, N-type doping. Here. So happened is red. Okay, N-type doping, N plus photolithographic. Okay. Then here P-type doping, P-type doping. This is P-type doping. So what is the difference? See here. Doping here also P-type doping, N-type doping. Now red. Here see here different. And then in a failed stages, N-type and P wells, active areas, PA capacitor, PAP capacitor, MOS gate, MOS source and drain. In wafer processing steps, here P-type doping. Already we have shown those slides. Here what is doing here? TEOS deposition in between this N plus plus 1 micrometer and plus P plus plus 3 micrometer T by S diffusion C. What is the changes? 2 layer. Okay. This is the star. Okay. This is see here. So N plus plus and P plus 3 micrometer is diffusion here going on. TEOS deposition. TEOS means T for tetrail. This T ortho O and then silicate ortho silicate. Yes, okay. N and P wells, active areas, PAP capacitor, MOS gate, MOS source and drain, PL stages, interlevel oxide contacts. Okay. After processing steps, TOS deposition in between these N plus plus 1 micrometer, P plus plus 3 micrometer into TS diffusion. Okay. Happened like this. Okay. Here in window photolithographic, P well, N well, window photolithography. So this is the window. This is the window. This is the window. This is the window. Window. This. Okay. This is not available.